wavelength, that could be a substantial amount of investment in time, unless you really want to optimize the resolution. So in this case here, I might go up to say 10 nanoseconds and 10 seconds to see if it cleans up for both wavelengths. I'm sacrificing some resolution, but I'm optimizing my duration a little bit. And so from a CapEx, OpEx perspective, that trade-off might be sufficient enough for me. And if I'm happy with these settings, all I do is save and go to the next fiber. And because I set incrementation on fiber ID, the next file name will be fiber 2, fiber 3, fiber 4. So in this case here, we're seeing a little bit of noise still at 1310. So if I go to next wavelength here, we'll see that we do have some noise here. So I wouldn't go with this trace normally. I would probably go back to the OTDR here, maybe increase my duration or increase my pulse width to see if I can get away with a better trace. So in this case, I increase my pulse width to 30. If I drop my duration down to 5, maybe I can offset each other. I lose some resolution, but I gain another 5 seconds or 10 seconds per test. So 5 seconds at each wavelength. So there was 1550 and now 1310. And 1310 is a lot cleaner. Still a little bit of noise there, but it's doing a lot better than it was before. And so if I'm happy with this, I would hit save. It would automatically save the trace. And then you'll see the next disappear here. Now it just says file name. And then now I'm testing fiber number 2. I would inspect and clean my connector as needed and go to number 2, number 3, number 4. And I'm just saving data. That's all I'm doing now, just testing and saving. So it's all routine from here on out. And you'll see how easy that was to set up. I mean, it's really not that difficult to set up an OTDR. The difficulty is really in the interpretation more than anything else. And so speaking of interpretation, you do that in the event tabs. So in the OTDR tab, we were setting all of the settings, range, pulse width, duration. The event tab, this is what allows us to look at the actual key performance indicators of the different events. So here's our launch. So we're launching 0.5 dB of loss at that connector. So this is basically my patch panel or my very first connector in my network under test. This is a little high. We usually want a half a dB or better. Reflection-wise, we have neg 53.5 dB of reflection. This is a UPC connector on the far end. So I would expect 50 to 55 at spec. So I'm really good here. I usually prefer it to be above about a minus 45 dB for a UPC connector or better. Here at 6 kilometers, we have an event. This is a non-reflective event, meaning we have loss but no reflection. This could be a splice. Here at event number 3,